Okay, our objective today is to talk about the distance formula and the midpoint formula. We are getting into more of the geometry concepts, which really leads us to chapter 10 and will really help you when you have geometry in 2 years. And again, your chapter 9 test, the earliest it could be is Friday. Okay, we're going to start with going over our warm-up today, which is the types of numbers sheet. And then we are going to go over practice 9.4. And I just realized I don't have all of them up there, but that's okay. We'll read through those. Okay, so -8. Amberly, can you read to us? What did you check off for -8? Good. Integer, rational, real. And I just put the symbols up here because I couldn't fit the whole thing on here. Camille, how about -7.1? Good. Rational, real. 0.006, since I already pulled it down. Rational, real. 0, Ray. Yep. Good. -2.6, Skylar. Careful, it can't be integer because it's a decimal. Maybe you didn't know it was a decimal. Does it just look like -26 on yours? Okay, then we'll go with that. Never mind, Skylar, you're good. On my paper, it looks like -2.6. We'll go with -26. So integer, rational, real. You're good. 17, natural whole, integer, rational, real. Geo, square root of 110. Good, irrational and real. 0.3 repeating. Alexis? Good, rational, real. -16/4, Abigail. And? Good job. And integer, because -16/4 is really -4. Okay, David, how about 17/7? Good, rational, real, and I ignore this. Rational, real. 3.75, Drew? Okay, well, you could tell us. 3.75, if it's a decimal. Good, rational, real. Next one is 3.141 repeating, rational, real. Next one is -37, integer, rational, real. Ray, want to do the next one? Any mixed number, improper fraction is rational. Yep. Ray, you want to do square root of 24 for us? Good job. Irrational, real. 1, Josh. Good job. Joseph, square root of -13. Oh, thank you. Say that again. Just good. Just imaginary. Yes. Square root of -83. Thank you. 16 should be natural whole, integer, rational, real. Negative square root of 36, integer, rational, real. -4.8. I guess I didn't have the rest of these. Kevin, -4.8. What'd you put? Say that again. Okay, good. I thought you said irrational. Rational, real. 5 3/8. Nathan M. Okay, what should it be, though? You can do it. Mixed number. And? Good. Rational and real. Michelle, 2 pi. Good. Irrational, real. Square root of 144, Jackie. Good. Okay, I'm going to read the next one. 91/7, natural whole, integer, rational, real. 75, natural whole, integer, rational, real. -11.1, rational, real. The next one, -78,250.1, rational, real. 435, natural whole, integer, rational, real. Negative square root of 72, irrational, real. 46.38, rational, real. Square root of 64, natural, whole, integer, rational, real. Any questions or repeats? Sorry, I forgot to put them all up there on any of those. Ben, you done? Just put on my desk. Thank you. Checked over everything, right? Okay, good job. All right, we good on the warm-up? Okay, let's go to practice 9.4. So practice 9.4. Okay, this was your assignment after the quiz on Friday, which I don't know why they have this again. I mean, I know that you need to know what type of number it is when simplifying radicals, but we learned this in chapters 2 and 3, so that's why I had you do this after the quiz. This was not really a review. This was a review. Okay, Joseph, we'll start with you. Number 1, is it rational or irrational? Good. Rational. Michelle, number 2? Good. Peyton, number 3? Good. Number 4, Nathan S. Good. Irrational, I can't talk. Drew, number 5. Good. Grace, number 6. Good. Number 7, Gio. Good. Number 8, Ray. Good. Number 9, Josh. Nope. Careful. Skylar, what did you get for number 9? Good. Should be greater than. Number 10. Ben, you didn't do yours, right? Okay. Amberly, number 10. Good. Nathan M, number 11. Good. Oh, man. Didn't mean to do that. Greater than. Number 12, Kevin. Okay. Yep. Yeah, the whole thing in square root, right? Okay, good. Neil, number 13. You mean 81 over 5? Okay. 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 Good job. David, number 14. Okay. 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 Good. Good job. Abigail, 15. Oh, careful. There's one that should be before that. That one is about 5.244. About. What? Okay, what did you have second? Yeah, that should be first. So square root of 75 over 2, and then square root of 55 over 2. So Abigail, from there, what do you have? You're probably okay on the rest. Good? Yep. Yeah, you're good. Just watch those first two. Okay, 16, Steve. Good, rational. And I think that's all they asked you, right? Yes. Number 17. Greta, did you finish your quiz? Then you're fine. Never mind. Drew, 17? Or you didn't get to that one, did you? No. Okay, Geo, 17? Good job. Irrational, and it was about 1.77 seconds. Number 18, yes or no really is all we need. Jackie, what'd you get for 18? Good. That one is yes, and I can explain that further if you guys need me to. And then 19, you just had to put this on the number line. So square root of 8 is about what decimal if you round, estimate? Neil? Yeah, it's 2.8. So you should have a point about right here. They made that a little more confusing than they had to. All you had to do was simplify it. Even though we're simplifying radicals and keeping them exact, they wanted you to just estimate it and put it onto a number line. Any questions on anything? Grace?
With the Northville Senior High morning
For 11?
Today's lunch is chicken nuggets.
You put less than you said? Okay, so number 11 we have, I'm going to move this for a second. We have negative square root of 8 and negative 10/3. So negative square root of 8 is about negative 2.82, I'm just going to estimate. And then negative 10/3 is negative 3.3 repeating. So this is greater than this.
of the United States of America.
Yeah. And I figured when they throw negatives in, it gets confusing sometimes, but it's always the opposite, as you know. She? On my desk. Thank you. Anyone else? Any questions? Let me go back to this. Any questions on anything? Nathan S., you're okay? You okay? Okay. Any questions on homework? Positive? Was that easy for the most part? Okay. All right, let's open up your notes to page 12. Bless you, bless you. Nathan S., you sure? Your allergies? Okay. If you need to go to the nurse, let me know, because they can give you eye drops that won't make them so itchy. Okay. Promise, the nurse is nice here. Okay, so page 12, distance formula is what we're going to start. So I don't know, maybe you guys learned this. Does anyone know what the distance formula is? Or do you have any idea of what it might be used for? Neil? Well, not the area around, but the amount of each side length. Okay, is what you mean. Yeah, the distance formula, we're going to find like the distance from maybe one side of a triangle that's on a coordinate plane, maybe from A to B, B to C. Gio? Yes, yes. So there is a formula that allows you to calculate the distance of a line that's diagonal, and maybe not just going straight horizontally or straight vertically. Okay, so we're going to have diagonal lines or maybe just two ordered pairs. How do you find the distance? That's what we're going to do today. What do you think the midpoint formula is, and what do you think it's used for? Or you can just answer one of them. Neil? Not the area. Okay, you're close. What Neil said that's correct is midpoint formula is used to find the halfway point of a line that you're finding the distance of. Your midpoint is the exact middle of a line. There's a word in geometry called bisecting that means the same thing. So if something bisects something, that means the same thing as you're finding the midpoint. It's the exact center of an angle or a segment. Okay, so that's the plan for today. We just learned the basics in this book. So if you learn the basics and understand it, when you get to more application in geometry, it should be much easier for you. Okay, we're going to skip that. We're going to go right to the box on page 12 where it says the distance formula. Do not write all this. I'm going to explain this. All you need to write real big is what I have in green here. Do not write all this. You don't need to. Just write what's boxed in green here. I'm going to explain the writing part. So again, just write D equals square root of. So let me explain. Real big in this box, real big. Guys, write the formula real big in the box. You have a huge box there. All you're writing in there is the formula. Okay? So you can just write that formula really big in the center. I have the writing there because that's what your book has. So the distance between 2 points in a coordinate plane is equal to the square root of the sum of the horizontal change squared and the vertical change squared. Michelle, you can go up here if you need to. Will that help you see? Do you have your glasses or no? Yeah, go get them. So the distance formula, very, very easy, should be pretty easy to remember, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. If you switch the order that you subtract, it doesn't matter. If you have the y's first or the x's first, doesn't matter. Here's, you don't need to draw this, but here's something that kind of shows you why this works. If we are finding the distance from this point to this point, this is labeled x1, y1, this is labeled x2, y2. How do you find the distance from here to here? Well, from here to here, you need to take the absolute value of x2 minus x1, which is the same thing as squaring it. You need to take the absolute value of y2 minus y1 on the vertical change, which is the same thing as squaring it. You cannot have a negative distance. So that's why they have absolute value there. You can't say, I took a negative 5-mile walk. That makes no sense. Even if you walk backwards, you're still walking. You're still running. You're still doing something. So your distance is always going to be positive. Keep that in mind. Okay, I want you to think back to what we learned earlier in the chapter. how else can we find this side? If we kept it as a triangle, how else could we find this side right here? Josh? Yes. So there's actually two methods for this. You can use Pythagorean's theorem if they give you a coordinate plane and something for you to figure out the length of this side and the length of this side. So do you always have to use the distance formula? No. Pythagorean's theorem is pretty much where they got that. So it solves for and finds the exact same length. Okay? So we are going to do method 1, which is using the distance formula. So right underneath example, okay, this is from the warm-up. So we need to plot A as 1, 3, and B is 5, 6. So the first thing I want you to do, I want you to write down 1, 3 in the box where it says use the distance formula, and B is 5, 6. And B is not going to fit very well on here, but we'll try our best. So let's plot A first, over 1, up 3, and I'm going to label that A. And then B is 5, 6. Go over 5, up 6. You're going to have to go up to here and connect them. Okay, I want you to label your point x1, y1, x2, y2. Okay, I then want you to write down the formula. Distance is equal to square root of x2 minus x1 squared. So always subtract the x values, plus y2 minus y1 squared. So until you feel like you know the formula, I want you to write it down. Okay, let's plug in what we have. So x2 is 5, x1 is 1. So we have 5 minus 1 squared plus y, whoops, if I could write a 2 here. Sorry, guys, I just realized that. I don't know. It's Monday for me, too, I guess. This should have been x2, y2, my fault. I wrote a 1 by accident. Thanks, Drew. y2 minus y1, 6 minus 3 squared. So make sure one of the ordered pairs is x1, y1. The other one is x2, y2. Gio? Right here. You okay? I thought I was making another mistake. Is everyone okay? All right, so order of operations tells us we need to subtract next. So 5 minus 1 is 4, still squared. 6 minus 3 is 3, still squared. Next step is square the numbers inside the radical and then add them. So we have 16 plus 9. And you do not need to do all of these steps. Once you get good at this, I'm sure you'll skip some steps. 16 plus 9 is 25. So what is the distance from A to B, Kevin? Good. The distance is 5 units. We do not know whether it's inches, centimeters, meters. So distance from A to B is 5 units. So not bad. Just plug in numbers in, right? That formula works to find the distance of any 2 points, whether you're given a graph or not. Okay, and that's chapters 1 and 2 of geometry. Okay, flip over your notes. I want to do method 2 with you. So same problem, but method 2 is using Pythagorean's theorem. So we had the ordered pair 1, 3 and 5, 6. So let's plot it on our graph. Again, so over 1, up 3 is A. Over 5, up 6 is B. So there's our diagonal. We need to make a triangle out of this so that we can check it with method 2, which is Pythagorean's theorem. If we make a triangle, whoops, out of this, how long is the base of the triangle? How long is the base, Camille? Good, 4 units. How many units is the height of the triangle? Kevin? Awesome. So we're going to use the 2 legs, which are 4 and 3 units. Yes, they are exactly that. If they're not exactly that, you cannot use this method, because how are you going to know whether it's 1.2, 1.25, 1.3, etc. So we have nice sides. So let's use Pythagorean's theorem. A squared plus B squared equals C squared. Sorry, I'm having trouble writing today. And let's see if we still get that C is 5, which, yes, you should. So let's say A is 4, B is 3. It doesn't matter which one you choose for which. So we have 4 squared plus 3 squared equals C squared. 16 plus 9 equals C squared. And as you can tell, yes, we are going to get the same answer. Do you guys like Pythagorean theorem better? Okay, that's because you know it. Yeah, but you won't always be able to, again, because the sides might always not work out to be nice ones. Steve? Because one of the order, after we plotted the ordered pairs, Steve, the base of the triangle is 4 units, the height of the triangle is 3 units. Anyone else? Okay. All right, let's look at number 2. So we're not going to graph, we're just going to find the distance, because typically you're just going to be given 2 ordered pairs, and it's going to say find the distance between these 2 points. So let's label x1, y1, x2, y2. So on number 2, let's label the ordered pairs, and let's find the distance. So distance is equal to square root of x2 minus x1. I'm going to start with the x's. So 5 minus 1 squared plus y2 minus y1 squared. 1 minus 6 squared. Then you with me? Okay. So subtract next and then square them. And again, eventually you can skip some steps. 5 minus 1 is 4, so we have 4 squared plus 1 minus 6 is negative 5. Keep the negative inside parentheses. If a number is positive, I technically do not need to leave the parentheses there, but I'm going to. Bless you. Distance is equal to, we have 16 plus positive 25, all in the square root symbol. Negative times a negative is a positive. That's why negative 5 squared is positive 25. We get distance equals square root of 41. Can we simplify that further? Mike, did you finish your quiz? Oh, okay. Sorry. I didn't see it on your desk. Neil? You don't think so? Does anyone think that we could simplify, Joseph? Okay, good. Yeah. There's not a perfect square that goes into this, so this is the answer. Just like Pythagorean's theorem, you need to keep this in form of a radical. You want it to be the exact answer. So you need to leave that as a square root. Do not change it to a decimal. If there was a perfect square that went into it, yes, we would change it. Okay? Okay, I want you guys to try number 3 on your own. So try number 3 on your own, and then I'm going to show you the midpoint formula. So I would label them x1, y1, x2, y2. Be careful with the negatives on this one. Good job. Is that a 65? This should be 1 minus negative 5. You forgot about this negative. That's why. Watch the negatives on this one. They try to trick you. Let me try that again. Negative 4 minus 3 is what that should be. A negative squared is a positive. Remember? Negative times a negative is a positive. All right, so first step, I saw some little mistakes here. Distance is equal to square root of -4 minus 3 squared, and then plus 1 minus -5 squared. Some of you forgot this negative here. When you have two negatives back to back, it makes a positive. So your second step should be -7 squared plus 6 squared. Watch your negatives. The formula is minus, so if you have those two negatives back to back, it changes to a positive. So you end up with square root of 49 plus 36, which is the square root of 85, and that is your answer. Square root of 85 units. Guys, okay? That's as hard as it gets. So pretty easy, right? As long as you know the formula. Do you guys agree or no? Okay. All right. I like the closing problem, but we're going to save that for tomorrow. So flip over to page 15 of the notes. I want to show you the midpoint formula because these two go together. It's all the same lesson. So flip over to page 15. So the midpoint formula is exactly what Neil said about 10 minutes ago. It's the exact middle point of a segment. So I want you to go ahead and jot down where it says define midpoint. It's the point on the segment that is equally distant from the endpoints. So it's that exact point on a segment that is equal distance from the endpoints. It's the exact middle, another way to say that. Should be writing that right there. So the exact middle, halfway point. Okay, in the box below, real big, I want you to write the formula. So I just want you to write this. Put a box on it. M equals, in parentheses, so M equals, really big in that box, x1 plus x2 over 2, comma, y1 plus y2 over 2. So it's an ordered pair. What's this kind of like? Why are you adding the x's and dividing by 2? What is this already kind of like that you know? Drew? No. I can see where you get that, but no, not like area. Gio? That's what Drew was trying to say. Neil? No. Greta? Okay, kind of. That's what Neil was saying. You guys can't think of anything else? What else? What other formula do you divide by 2 or divide by how many items there are? Joseph? Say that. No, that's what Drew said. Gio? Yeah, it's kind of like finding average or mean. Think about it. You're taking x1 and x2, there's 2 points, and you're dividing by 2, which is how many there are. So I know there's only 2 points, but it always reminds me of finding mean or finding average. So when you hear midpoint, I always want you to think of it, the formula is an ordered pair. You're taking the x values, you're dividing them by 2. You're adding the y values, dividing them by 2. Always. Here, you don't need to draw this, but here's a little picture from your book that shows you, here's x1, y1, here's x2, y2. To find this point right here, you're always taking y1 plus y2 divided by 2. To find the midpoint, the x, you're always taking x1 plus x2 divided by 2, which is up here. So just a little fancy picture. You will prove this eventually, just not in this book. Okay, let me show you how this works. Let's start with number 1 and let's plot the points on this one. There's only one way to do this. like the distance formula, you can use Pythagorean theorem. This one, it's just the midpoint formula. So let's plot, I'm going to call this one A and this one B. 2, 4, so A is right here, and B is 5, negative 3, which is right here. So I'm going to connect them. We need to find the midpoint, which is the halfway point, which is equidistant from each of the endpoints. I'm going to label them x1, y1, x2, y2. Midpoint formula is very similar to average. So we're going to take midpoint equals x1 plus x2 divided by 2, y1 plus y2 divided by 2. So I'm just going to write the formula out. Now we're going to actually use it. So midpoint is equal to 2 plus 5 divided by 2, comma, 4 plus negative 3, which is just 4 minus 3, divided by 2. Josh? Say that again. No. I was going to say, I definitely have been making mistakes today. No, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. You okay? Okay, so add first, and then if you're able to, divide by 2. 5 plus 2 is 7, so 7 over 2. 4 plus negative 3 is 1, so 1 over 2. So you can leave your answer as 7 over 2, comma, 1 over 2, or 3.5, comma, 0.5. That's up to you if you want to leave it as a decimal or as a fraction. So our midpoint would be right here, over 3.5, up half. Now my drawing is not perfect, but that's our midpoint. Abigail? Well, but we're not solving an equation, we're simplifying an expression, but I see what you're thinking. I'm glad you're thinking like that, though. Gio, were you going to say the same thing, or? You okay? Okay, so our midpoint, if I could draw perfectly, would be where that dot is. Obviously, that's not exactly perfect, but it's a halfway point. Okay, let's try number 2 together. Then I'm going to have you guys try one on your own. Okay, number 2, we need to find the midpoint of 3, negative 5, and 4, 1. So I'm going to plot these real quick. 3, negative 5 is right here, and negative 4, positive 1 is right here. Connect them. I think it's good when you first start doing this to plot the points to make sure that your midpoint is the halfway point of the line. It's a good way to check. So x1, y1, x2, y2, we're going to label them. Midpoint is always an ordered pair. x1 plus x2 divided by 2. So 3 plus negative 4 divided by 2. And then negative 5 plus 1 divided by 2. So add the x's, divide by 2, add the y's, divide by 2. So add them next, then divide by 2. 3 plus negative 4, or 3 minus 4 is negative 1 over 2. Negative 5 plus 1 is negative 4 over 2. And then simplify. So we have negative 1/2, comma, negative 2. And again, you can change it to be negative 0.5 if you want, and negative 2. If we go over to the left 0.5 and down 2, we're about right here. And again, if I could draw perfectly, that is the midpoint. So that's your answer. Any questions on that one? Okay, flip over. Oh man, I forgot there weren't anymore. Well, that's okay. Let's do 3A together. Sorry, I was going to have you try a midpoint on your own, but there aren't anymore. 3A is a review. We're just going to do 3A together, and then I'm going to explain your homework. Something that we're going to do tomorrow is applying the slope, midpoint, and distance formula. So do you guys remember, without looking back, what is the slope formula? David? Awesome. Slope is equal to y2 minus y1 over x2 minus x1. In geometry, the book really, really loves the distance, midpoint, and slope formula. You will see them a lot. So we are going to relate these tomorrow. I wanted to show you the formulas today, give you a chance to practice them, and then tomorrow we'll relate them all. So let's find slope, just as practice. We'll do the other one tomorrow, or just as review, I should say. So y2 minus y1, we have 5 minus 7, all over x2 minus x1, so negative 2 minus negative 4. Watch those negatives. 5 minus 7 is negative 2, and then negative 2 minus negative 4 is really negative 2 plus 2. Sorry, negative 2 plus 4, which is 2. So we get our slope is negative 1, which is your rise over run. You could also write that as negative 1 over 1. Okay, so everyone remembers that, right? Okay. So any questions on distance formula, midpoint formula, or just a review of slope? Okay, I want you guys to open up your homework packet to 9.5. We're probably still going to do a little bit more of this tomorrow, including those application problems. So on practice 9.5, just give me a second here. Okay, I want you to do 1 through 16, and hold on, 19 through 21, 25, and 31. So not all of it, just the ones that I have up there. So 1 through 16, 19 through 21, 25, and 31. On 1 through 16, 1 through 4 asks you to find the distance between the points. What I recommend doing first for 1 through 4 is going to A, B, C, D on the graph, write down what the ordered pairs are. For example, letter A is negative 5, comma 5. If you write the ordered pairs wrong, all of your distance formulas are going to be wrong. So letter A on the graph is negative 5, positive 5. I would do that for all of them. Ray, take your homework out, please. Do that for B, C, D, and then carefully find the distance. Do not change your answer to a decimal. Keep it as a simplified radical. Okay? You may need scrap paper. They do not give you much room. Show your work. So when we go over homework tomorrow, if you miss something, we can figure out why you got it wrong. That way you're not going crazy studying for the chapter test for this chapter. 5 through 10 is also the distance, but they give you the ordered pairs. So label them x1, y1, x2, y2. Simplify everything completely. Do not change your answer to a decimal unless for some reason they give you decimals, like in number 8 and number 10. 11 through 14 is very similar to 1 through 4. You're finding the midpoint. You need to list what the ordered pairs are on the coordinate plane before you actually go ahead and find the midpoint. And then 15 and 16 find slope. The rest of them, same thing I just explained. Greta? Yes. Yes, after the quiz. Not the lesson. It's a review. We didn't do the lesson. They just did the worksheet. We already technically talked about, remember all the types of numbers in September? So they did that after the quiz because we had a lot of time. So, yeah, no rush for that. Take your time. Any other questions on 9.5 or anything? Okay. And just a reminder, your Chapter 9 test, the earliest it'll be is Friday. I'll let you know tomorrow for sure. We may want to wait until the beginning of next week. Okay? All right. You guys, hold on, let me see who's first today. Boys are first, so when you guys are ready, you can get packed up. Good job today.